Okay, take out. Class, can I have your attention? Let's do the collection later. Yes. Right now, you can use your calculator. So just use. Okay? Alright. Can I have silence? You all don't need to put your fingers to your lips to keep quiet, right? Right, Brian. Right, Zheng Hong. They don't even know I'm talking to them. And listen. Question 1. Any problems with this? 1A. 1A. A. Okay, part A, we have to show that CA, which is this light green line, intersects BCO. That means if it intersects, this angle over here will be 25, the other side also 25, right? So can we go about proving that? Okay, so let's look at the first step. We can find out what is angle OCB. It is actually 180 degrees minus 130 degrees because of interior angles. This angle over here and this angle, they add up to be 180 degrees. Okay, so OCB is 50 degrees. What else? Since we know that O is the center of the circle, A and C are the circumference, are points on the circumference, then OA is equals to OC, which are the radius. Then if we join A and C, we get an isosceles triangle. This isosceles triangle has two same base angles. They are 25 degrees. So we have proven that OCA is 25. We have shown that OCB is 50. So therefore, since OCB is 2 times of OCA, then CA must bisect angle BCO. Can follow the logic? Okay, part B. Part B, whole thing okay? B part 5. Before I go there, any other parts? Don't worry too much about copying because I will put it online. You can go ahead and copy at your own time. Okay, so angle DBA, where is it? DBA. Okay, that's my part 5. Okay. By the way, I'm surprised nobody asked me about part 3. Part 3 requires something that is not in your syllabus. You actually managed to do it. Yes. Okay. The easiest way is to use something not in your syllabus. That's why I put it in red color. If you can't solve it, don't worry too much about it. So let's go on to part 5. We want to find angle DBA. DBA. Angle DBA is equals to angle DCA. DBA and DCA, they are in the same segment. So reason stated. And what is angle DCA? DCA is 24 degrees plus, earlier on we found out 25 degrees. So just add them up, we get 49. Okay, so moving on to question 2. Part A, any issues? B? Okay, everybody stop writing, because I don't want a case when I move on and you haven't checked whether you need me to go through or not. So stop writing. Question 2, need me to go through? Question 3. 3C. Anything before that? Okay, let's look at 3C. Okay, I checked with the teacher who prepared this. There was a typo inside. So this should have been given that Zx is equals to 7. So please change it first. Okay, so Zx is 7 centimeters. Find the radius of the circle. So I chose to look at this green triangle. Okay, ZOT. ZOT. It is a right angle triangle because ZT is a tangent to the radius. So tangent to radius, this over here is 90 degrees as shown. Then we have our point X, point T. They are the same distance from O because they are the radius. Okay, so this is the part of the circle. So I have 7, I have an unknown over here which is radius and radius. So sine 30 degrees will be your opposite, which is r, divided by your hypotenuse, which is 7 plus r. Sine 30 is just half. You have one equation with one unknown, you get r equals to 7 as well. Okay? If you can't see at the back, please move forward. Ikpin can see? Clear or not? Okay, let me move on to question number 4. Part A, any problem? Part A. Part B, showing that they are similar. Are you able to do it? Who needs me to freeze at this point for you to copy? So okay. Question 5, Part A, Part B, Part C. Okay, good. I want to draw your attention to Part C. We are trying to determine whether BO and AE are parallel. So I highlighted it in this light purple color. How can we go about doing that? We know many properties of parallel lines. For example, what did Mr. Tan use? Fuso, right? And one last one was angles at a point. Correct? So these are your parallel lines. So over here we have your corresponding angles, interior angles, alternate angles. You know all these rules. How do we apply it here? So what I did was, I tried to find angle OBE. OBE. So this portion, and I found out that it was 23 degrees. Now, if they are parallel lines, then OBE should be the same as BEA, isn't it? If they are parallel lines, these two are alternate angles and they should be the same. But I found out that OBE is 23, which is not the same as AEB, which was given to be 24. Therefore, I can conclude by alternate angle theorem. So this one over here. By alternate angle theorem, AE is not parallel to BO. I think in the answer key given to you, they didn't write this down. We need to see this. Okay, so please include this portion. Let us go on to question 6. A, does anybody need help? 6B. Six C. Okay, 6C is part 1. Quite a unique question. Let me just spend a bit of time talking about it. I singled out this triangle in dark green. Triangle CDE over here. CDE. And we have found that the angle DCE and DEC are both 50 degrees. In other words, this is an isosceles triangle. They didn't tell you it's an isosceles triangle, but because the two base angles are the same, you conclude it's an isosceles. Okay, then we can use our sine rule, where CE over sine CDE is equals to CD over 50. Okay, so because it's an isosceles triangle, you can find out from the angle sum of triangle, we find out what this value is. So C will just be CD over sine 50 times sine of 80 degrees. So it is of the form that was required in the question of CD over sine A, where A is equals to 50 times sine B, where B is equals to 80. So this is what we show. And for part 2, since they are both, what did I write? C part 2. Okay, since they are both isosceles triangles, and we know that they are similar, we can write down area of triangle CDE over area of triangle CDG is equals to CE over CG square. Okay, they are similar triangles. And in the earlier part, we have CE equals to this. So I'm going to substitute inside here. So CD over sine 50 degrees times sine 80 degrees divided by CG square. And CG is equals to 2CD. Let's replace it, 2CD. Why are we doing this? So that we can cancel here and here. So my final answer will just be sine 80 degrees over 2 sine 50 degrees. Our answer, find out what it is, round it off. And you get 0.41. Ik bin. Did you do your work? Why not? Did you do your work? Yes. Did you do it? Are you going to be able to submit it to me tomorrow? Doesn't mean you should be sleeping, huh? My students here are independent workers. You can be trusted to do your work. If I find that you cannot keep up in terms of the rigor that is expected of you, it means you need somebody to watch over you very closely, and that person I recommend will be Miss Tan. Then you go to her class. Okay? Now, question 7. You have checked your answer in the answer key. Any parts you need me to go through? 7A, 7B, C, D. All okay, huh? Then let's go on to question 8. A. How did you explain that EAB is a right angle? Yes, we are using angles in a semicircle. So to explain why EAB is a right angle, we hope was it given in your answer key? Yeah, it is already given in your answer key, so I'm not going to write it out. 8B. Any problems? 8C. 8D. 8D also okay? Alright, then moving on to question 9. Nine A, 9B, 9C. Still no questions. How many of you haven't done question 9 onwards? 3 of you. 4. 5, 6. The rest have done the whole thing. So those who have not done it, you are unable to tell me whether you have problems with it. Alright? Since you are unable to tell me whether you have problems with it, when I ask whether you have questions, you cannot decide whether to raise your hand or not. So I'm going to move on. That means you are losing out. I am not explaining that part. Can you see the importance of why you need to finish your work before you come to class? Otherwise, I'm moving at the pace of students who have done their work. So I don't want to see this happen during the next lesson. Question 10. Question 10, huh? Okay. This is a very interesting question also. Let us assign names to the points. Okay, let's call this P. This point over here. Let's call the center Q. This center, let's call it aura. Let's call this center S. Let us also give letters, assign letters to the different radius. Okay? So let this big radius, let it be A. Let us let this radius be B. This point aura. And the small radius shall be C. So if I list it out, okay, let P be a vertex of triangle. Q, aura, S are centers of C3, C2, C1 respectively. Let radii, cause more than one, of C1, C2, C3 be A, B, C respectively. Okay, now I have labeled all of them. This is an equilateral triangle. So all the angles of the triangle are going to be 60 degrees. What else can we tell from this? What about this big circle? This big circle sits right in the middle of the triangle. We divide this triangle, this circle, into 3 equal parts. And we know that these angles are going to be 360 degrees divided by 3. Right? So this will be 120 degrees, 120 degrees, and of course for this. Now, you need to draw an important line. Okay? From P, cutting through all the radius of the 3 circles. Draw a line. Cutting through all the radius. So this triangle is what we are going to be focusing on. First, can you tell me what is this angle? 60, yes, because we split it equally into 2 parts. So this is 60 degrees. Okay, now I'm going to enlarge this diagram out over here. And we know that this is 90 degrees also because its tangent is perpendicular to the radius. So this is my 90 degrees, 60 degrees over here. Then my first circle cuts here. This is A, the radius of the first circle. Then I have another circle. It has a radius of B, so B and B over here. And finally, I have my smaller circle. It has a radius of C. So if the center is over here, I've got C and C. Okay, and this over here is point P. Where is my point Q? Point Q is here. Where is point R? It is here. Where is S? S is here. P is here. Okay, so far you can see this diagram. You see what the different positions tell you. Okay. We are now ready to form equations. What is cosine 60 degrees? Cosine 60 degrees over here will be my adjacent over the hypotenuse, which is A over PS. Because this is also A. Cosine 60 degrees adjacent over your hypotenuse, which is PS. That is my first equation. And use your calculator, you find out that cosine 60 is half. In other words, PS is equals to 2A. Okay? Then we now try to express the same thing for PR and PQ. Cosine 60 degrees is also equals to B over PR equals to half. Therefore, PR equals to 2B. And the final one you'll get PQ equals to 2C. Okay? Let's keep this in mind. Then we also know that PS, the entire thing, is made up of 2C, this part, plus 2B over here, plus A, and plus C over here. This is also C. Okay, simplify it, and we get this is supposed to be, if we simplify it, we will get 3C plus 2B plus A is equals to PS. What else do we know? PS is also equals to 2A. Then now we can write down 3C plus 2B is equals to A. This is equation number 1. Then again, PS is also equals to 2B plus B plus A. This is simplified to become 3B equals to A, because this is also equals to 2A. Okay, so our second equation is B equals to A over 3. Substitute equation number 2 into equation number 1. We get 3C plus 2 times of A over 3 equals to A. Simplify, get C over A equals to 1 over 9. What we are doing over here is to play around with how we express the different line segments in terms of A, B, and C. I have the work solution here also. I will also upload this, okay, in case you cannot read my writing. So you can refer to my voice in the video, and you can refer to the hard copy, the soft copy of the work solutions that I will upload also. Okay, then question 11. Question 11, part A. Any issues? 11, part B. Okay, 11, part B. Part A, we have shown that triangle EBD is similar to ECB. So whenever you have this, you should have your sketches. E, B, and D. And in the same orientation, the other triangle. Okay, so besides Wen Chen, anybody else needs me to go through this question? Gabriella, are you okay with this question? Part B. Then you never say. Otherwise, I would have gone on already. You must say if you have problems. So in the same orientation, this will be E, C, and B. And this one over here is a right angle. Right angle. BE is 10. EC is 26. And you realize that BE is also here, isn't it? Right, Gabriella? BE, 10 and 10. Okay, so far? Then you see the key already lah. Then you can find out what is this. You know what this is. And then you can find your answer for CD. Question 12A. A? Okay. Question 12A. Let's try to understand the question. Radius, aura. So over here, aura. And this is also equals to aura. AB is perpendicular to the chord. And this portion here is x. So this must be aura minus x. Okay, then where's the 9 cm? AB is 9, CD is 6. Okay, now let us look at the diameter. 9, AB is 9 plus x is equals to diameter, right? Which is 2 aura. So we want to express x in terms of aura. So x is equals to 2 aura minus 9. Okay? Part B. Anybody needs me to go through? Karthik, okay with this question, part B? Okay, then question number 13. Question 13, part A. B. 13 B. Karthik? C. Okay. Given that x lies on the circumference on the same side of the semicircle as point B. So this is diameter, I have two semicircles over here and over here. Where is point B? Over here. So X lies on the circumference somewhere here. X is somewhere there. Such that Gx equals to Ga. Where is G? Okay, Gx is equals to Ga. Ga is over here. Gx will look like this. Okay? This is my point X. It lies on the circumference, on the same side as B. And they also tell you that Gx is equals to Ga. Does this remind you of one of the properties? Tangents is perpendicular to the radius. Okay, what else? Exterior point, right? In your answer key, it was given to you. Gx is a tangent to the circle. The reason is tangents from an external point. Okay? This property over here. If this is a tangent, this is also a tangent, then these two lines are same in length, where this is the external point we are talking about. Okay, question 14. A. B. Do you need me to go through part B? Explanation. We are just using angles in the same segment. Angles in the same segment are equal. So that tells you that the point G cannot lie on the circumference. It is either going to be inside or outside the circle. Since the angle is larger than 70 degrees, which is 75 degrees, this is greater than 70 degrees, that tells you that it is going to be inside. Okay? So for example, where is the BXE? BX. So BXE, we already knew that it was 70 degrees. And then BGE, any other, we are fixing these 2 points. G, it can lie inside or it can lie outside. And you see that if it is outside, this angle will be smaller than 70. Whereas, if the point G is inside the circle, this angle will be greater than 70 degrees. Okay? So that's how we conclude that it lies inside the circle. Question 15. Part A. Part B. C. D. And E. No questions. Okay? Then you can keep this set